Good morning, Dallas. Good morning, San Diego. And good evening to or good afternoon to the other people who live in different parts of the world. Welcoming to Global Electronics Friday Talk Show with your host, Rajiv Kulkarni. And today is December the 13th and 2024. We are almost through 2024, another couple of weeks, and then we are in 2025. So today's topic is very interesting topic, and as we all know, electronics manufacturing is getting more and more challenging and more dense. Circuits have been produced as the technology advances because every year we come out with some new gadget. Every year we come out with new designs in the existing gadget because the need of the human being, the need of the hour is getting changed every moment of our life. Whether it can be electronics, whether it can be medical field, whether it can be aerospace, or whether it can be consumer electronics or automotive needs. You know, if you look at the today's automotive section, I mean, there are like, I would say more than 100 sensors, right? And in earlier days, we never used to focus on those, little bit of things, but electronics is getting more and more so challenging and so complicated that it is beyond our imagination. But today's topic is all about, again, electronics manufacturing, how important it is in the manufacturing sector, the cleaning process of the boards or the boards after the components being stuffed on the boards, right? It's rather than just cleaning, I would also say innovative solutions in cleaning. So we have today a special guest, and which I will introduce to you all. But before that, let's have a quick look at this video.
Who is KYZEN? Glad you asked. KYZEN is the leading global supplier of cleaning chemistries designed for high reliability manufacturing applications in a variety of industries. Industries that include electronics manufacturing, cleaning those circuit boards and other microelectronic packages that make the latest technology work, and metal finishing. Everything from ball bearings and screws to replacement knees and rockets. We don't just sell cleaning chemicals, we provide cleaning solutions from start to finish, including state-of-the-art process control and optimization products, analytical lab services, as well as providing cleaning process testing and development. We make sure our products work like they should every time. We are the place where science and care converge. We partner with our customers, making sure they have the tools, services, and support that they need to produce quality and reliable products. We do all of this with a global team that is dedicated to putting the customer first, embracing continuous improvement, all while having fun. To find out more, reach out to a member of the KYZEN Clean team or visit our website at KYZEN.com.
That is simply fantastic, video clipping, I would say. So let's come to the guest introduction. He is the Director of Science at KYZEN Corporation, utilizing his years of experience in the aerospace and electronics manufacturing industry to drive innovation in cleaning technologies. He received both his Bachelor and Doctor of Philosophy degrees in chemical engineering from Clemson University, where his studies focused on fluid phase equilibria and polymer thermodynamics. During that time, he authored multiple peer-reviewed journal articles, a textbook chapter, and a patent. Since then, he has authored, presented, and chaired at various technical events related to surface mount technology. Prior to his role at KYZEN Corporation, he was an engineer in the Materials and Process Lab in the Specialty Engineering Department at L3 Harris Technologies, where he supported space, maritime, and avionics programs with material characterization and selection, process development, and failure analysis. He is the Global Board of Directors panel in the Surface Mount Technology Association and contributing strategic insights and expertise to guide the organization's growth ensure operational excellence, and drive innovation in the dynamic field of electronics manufacturing. Ladies and gentlemen, let's welcome Dr. Adam Klett from Kaizen. Adam, good morning to you. How are you this morning?
Good morning, Rajiv. Good. Thank you for having me.
Absolutely. It's always a pleasure to see you, either this way or in person during, many events and many shows that we encounter and we meet at those shows. And it's always, pleasure to listen to you about your talks, in the cleaning technologies domain space. Absolutely fantastic. I know it's a little early, but I think it's Friday. It's fine. People can still watch.
Yeah,
People are at ease, And the best part is in Asia, it's already weekend has begun, and
that's true.
the people can still, relax and watch, unless they are, really strained out in the entire week of work. They want to just carry on for the next day. But let's come to our, beautiful, I would say, interactive session today, what we are
Hmm.
going to have. And I'm pretty sure, the global electronics main strategy or main point of this talk show every week that I held is to share the knowledge and, that we have. Whether it is through experience, whether it is through our academic background or so and so forth. And
Right.
it's very important for the engineers to understand what exists there. And that is the whole idea of this platform, so that people can make best use of it.
No, that's
So,
great. I love the idea.
so Adam, before we start, just a few things about you. If you can tell, how you got into engineering, what made
Yeah, of
you,
course.
yeah, yeah.
So I started school. My technical training is in chemical engineering. So I got both of my degrees, my bachelor's and my PhD in chemical engineering. Like you mentioned, I focused on fluid phase equilibria and polymer thermodynamics. So I have a lot of background on the technical side of the solvents, the interactions, how they interact with each other, and things like that. And then I started working at an aerospace company like you mentioned, working in a materials and processes lab. I spent a lot of time supporting the manufacturing lines in this company, failure analysis, material characterization, all of that type of thing. So I have a lot of experience troubleshooting some pretty hard problems, especially on the manufacturing line. And then now I work at KYZEN Corporation. Like you mentioned, I'm the director of science here. I have the privilege of overseeing a lot of the research that we do, looking into either new chemistries or new technology for the next level of cleaning advancements.
Excellent, excellent. That's a beautiful intro, and I would say that that passion and your academic thing have added to what you're conducting the role in your company now. That's really good. So let's come to our main theme of the today's show, right? The
Yeah.
topic, right,
Hmm.
about cleaning, innovative cleaning solutions. So what
Yep.
exactly is cleaning in electronics manufacturing, and whether it can be bare boards or assembled boards
Yeah,
to
that's a
begin
great
with.
question. So there are the cleaning steps from the very beginning to the very end. And what I mean by that is you can clean your bare assembled boards, or you can clean the components, or you can clean within the manufacturing of the specific components. And we'll probably get into this in a little bit. But, there's cleaning steps along the entire way. Generally, when people think of cleaning in electronics, they think of either an inline cleaner, which is essentially like a big car wash, right, where they're putting their final assembled circuit assemblies through to get flux residue is the biggest thing that
Yeah.
people think of. There are also batch cleaners where you can put they look like a big dishwashers, but that's what people think of when when they think of a cleaning process on a manufacturing line. But During the cleaning process, you have to realize that, and one of my colleagues in the industry puts it very nicely. Flux is the only contaminant that we intentionally add to these types of assemblies. But there are
Mm.
all sorts of contaminants that end up there. Everything from manufacturing residues. There are lots of different materials that go on these, right? There's solder masks, there's conformal coatings, there's plating residues that might be present. There might be human residues, fingerprints, food oils, things like that. There's adhesives, gap fillers, tapes, you name it. So there's all sorts of contaminants on these circuit boards. And so that's why we want to clean them, because we know that certain contaminants can cause reliability issues down the road, especially in high reliability applications. And so when we say we're going to clean, we need to take into account a lot of different factors. So, for example, what we're cleaning, what we're trying to clean off the board. There's material compatibility issues. We have to think about, what else is on the board that we want to clean, right? So it's kind of a difficult problem, because if I hand you a board and say, "Hey, I want you to get rid of all the residues, but everything else has to stay behind," and you want to,
Yeah.
leave everything working and functional. So it's almost like selective removal of certain residues, and so that can be challenging at times. Now, and in some places of the world, people have requirements for even particulate matter. I've sat in on various talks at industry or conferences like SMTAI and things like that, where there are presentations about particulate matter, cleaning after a board gets routed, or dust particles, or lint from your shirt, because some people have found that affects the like the stencil printing step within an SMT line. If you have particles present, it might cause alignment issues or transfer efficiency issues and things like that. So cleaning I think it's a lot deeper than a lot of people think, because like I said, at least when I started in the industry, when you asked me, "Hey, what is cleaning?" I just thought of that car wash looking machine where the boards go on one side and they come out the other, and
Right.
that was my vision of cleaning. And then once I started going to the conferences, reading papers, becoming involved in the process, it's a much bigger industry than I had
Yes.
originally realized. Yeah.
Wow. That's very interesting insight of it. So, I mean, what can be the goals and processes engaged in the cleaning process?
So the main goal, right, is to remove all of those residues that we talked about and
Yeah.
to make the board more reliable. Uh, like I said, flux is the only residue that we intentionally add, but there can be all sorts of other residues present on the board. I recently published a paper and presented at SMTAI, where I looked at different sources of ionic contamination that are present within a manufacturing line and in a testing laboratory. And it was amazing that we found that pretty much every tool and tooling aid and material that we had some sort of transferable residue. In our case, we were looking for ionic
Hmm.
residues, but everything that we touched and tested had some level of detectable ionic contamination that could potentially be transferred to the board. Right.
Okay.
So the goal of the process is to remove all of that, because we know that in certain high reliability applications, that those boards are susceptible to certain failure mechanisms. Now there might be, a lot of people clean because if they're going to coat, residues can prevent the coatings from sticking. And there are other reasons why you might want to clean. The biggest reason that I see cited is because electrochemical migration, things like
Mm.
dendrites forming, you get calf, and um, even tin whiskers have been reported to be a function of, very, very dirty boards. I read a paper recently that said that, very significantly dirty boards grew dendrite or grew tin whiskers more, right? So we're trying to
Oh.
prevent these failure mechanisms, right? Because we know that especially ionic contamination, because of the electrochemical reactions that can happen at the pads of biased traces on a PWB, if water condenses onto there. I mean, think of a circuit board that is not, or at least a high reliability circuit board that's not in some sort of harsh environment where, there might be some humidity changes, or there might be some, maybe high temperatures and things like that, where, water can condense on the board, and then you end up forming they're dendrites. And for those of the viewers who aren't familiar, dendrites are basically they're small. They look like little trees, and it's an electrochemical reaction that happens, and the ions will plate themselves onto. They'll move from one bias to another, and they'll plate, and they'll form this like tree, this dendrite that grows across that path. And it's a it's a metal wire essentially, and it can short it out, and it can cause failure. And so I'll say there are a lot of people and a lot of manufacturers who don't clean because they don't need to. I mean, think about like your dog's chew toy that lights up. You squeeze the toy, it makes a little noise, and then it lights up, right? Do you care if it fails? Like, you buy it, it's probably $2 or $3 at the store. Your dog chews on it for so long, and the saliva gets in there, and then, the electronics fail. So what, right? No one, try convincing a contract manufacturer to spend money on that process to clean the board when they know it's going to go into a dog's mouth and then, get broken anyways. Or, that's an extreme example, but, there are plenty of examples like, your toaster oven, or, things like that where, okay, it's an electronic. We don't need to clean this because if it breaks, there's no risk to life. No one's going to get hurt, and it's not a significant financial burden on anyone.
Yeah.
Right. If the toy dies, then you go to the store and you spend another dollar to buy it.
Right.
But it's the high reliability applications that require the cleanliness, right? We're talking things like airplanes, satellites, a lot of communication devices that rely on boards to function correctly all the time. And they can't afford for something to go down because someone might die. You can imagine if you have an electric vehicle driving down the road, and a dendrite starts to grow in there, and it shorts out part of the battery management system, and it catches fire, or the car just completely stops in the middle of the highway, right? That's a big problem.
Absolutely.
And so those are the goals of the cleaning process, is to make sure that we can create a product that we know is reliable for those situations that require it.
Excellent, and beautiful explanation, I would say. So the next question I have here is, what are the leaded versus lead-free assemblies cleaning?
Okay. Yeah. So I'm sure everyone here understands the difference between lead and lead-free and why we transitioned, right? Lead is harmful. We don't want it everywhere. There are still a lot of applications out there that use them, a lot of exemptions from certain regulations. A lot of times it's aerospace and high reliability applications where they are still allowed to use lead. For the most case, a lot of manufacturers don't need to worry about leaded parts. The reason that people don't like moving away from lead, or at least those high reliability applications don't want to move away from lead, is because of the reliability, right? There are a lot of historical data that has shown that, that there aren't as many problems, or maybe the mechanical properties or the reliability is just better with the lead. Now, I'll caveat that by saying that that's not 100% true. I have seen cases where lead-free alloys have shown better properties than the leaded ones themselves. But from a cleaning perspective, I'll say that today, right, with the advanced cleaning solutions that we have, the end user really doesn't need to consider that when they are making a selection in chemistry. Because so if you think historically, and especially near the time when that shift occurred, you're using a different alloy. The flux manufacturers may have put slightly different activators in those fluxes, which may have changed the way that they are cleaned, or their ability to be cleaned. The second thing to consider is that the lead-free alloys reflow at a higher temperature, right? It's 30 to 40 degrees C higher, right? So you're taking that to a higher temperature. And generally speaking, the hotter you take those organic residues, the harder they are to clean. I mean, think about you on your pan, like when you're cooking and you have, food residue in the pan, it's a lot easier to clean it right after you're done cooking, right? As opposed to, let's say you turn the heat up and you just let it like burn onto the pan, right? It's going to be a lot harder to clean. There are a lot of chemical reactions that can happen: pyrolysis, oxidation, polymerization. Sometimes there's polymers in there and they cross-link and they can become very hard to clean. And so those were the challenges that cleaning manufacturers faced in years past. Nowadays, they have come up with new solutions that don't really require a distinction between the two. I mean, we can use a cleaning solution for leaded or lead-free because we've engineered those to be able to clean both. Right, so that's not too big of an issue. Now, I will say that one thing that we have to take into account is the fact that lead is a soft metal that can be easily, it can be reactive to some cleaning chemistries. And so another advancement that has been made is in the use of additives to make sure that those don't dull. So I don't know if you've seen, sometimes when you get a solder joint, it's nice and shiny, and there are actually you get nice shiny side, and people like that, right? People don't like to see dull, like a matte finish solder. It just doesn't look very pretty, and a lot of customers don't like that. And so the reason for that is that sometimes the chemistry can etch away at the lead. Now it's not necessarily affecting the performance or the function. It's purely aesthetic. But people don't like that. And so we have, designed the cleaners to make sure that doesn't happen in those applications. But those are the biggest differences between lead and lead-free assemblies in terms of cleaning.
Excellent. And now, I mean, there are other questions also, which we will come back after this small, quick break.
Okay.
So welcome back to Global Electronics Friday Talk Show. This is your host, Rajiv Kulkarni, hosting every Friday about the electronics manufacturing and the challenges and the ups and downs that we face in the electronics manufacturing globally. So this particular episode or this show is mainly to cater the knowledge sharing to all the engineers out there, the electronics technology officers, and there can be CEOs and the presidents of the companies who are into the electronics business. So it's overall, to give some kind of electronics manufacturing knowledge sharing, mainly on the technical side, because that is very challenging. It has become more and more as the circuit becomes more and more dense, and the need of the electronics design has been evolving every single year because of the gadgets have been getting upgraded. Today's talk we are having with Dr. Adam Klett from KYZEN Corporation, and so far he has been absolutely giving brilliant solution about the questions that our audience have asked. Thank you very much, audience, for putting those questions beforehand so that we could address that today in this particular show. Adam, welcome back to the show after this small, quick break. Cleaning process on advanced packaging, how it gets involved, right?
Yeah.
That is because advanced packaging has become very, very important factor in today's electronics world that we all are facing, you know. So if
Oh,
you
yeah.
could throw some light on that, please.
Oh, of course. Yeah. So I think advanced packaging is one. It's allowed a lot of technical advancements within the electronics industry. Right? Things are getting smaller. You can pack in multiple dies on the same package. You can get much better functionality with those components. And it's really allowed, I mean, it's almost, I'm not going to call it a revolution, but it's allowed a big step in electronics manufacturing, right? I think what people don't realize, or what a lot of people see, right, is the final product. They see that the chip that they're going to then solder down to their board. But there's a whole process that that goes into making one of those, right? So there's steps. You have to start from the die level, whatever the semiconductor is, whether it's silicone or silicon or whatever it might be, right? And then you have to, add all the functionality to that. You might have to add, photoresist layers and different metallizations and things to create, the interconnects, the transistors and everything on there. And then that has to get attached to some sort of like an interposer type material. And then that needs to get bonded. And then that goes on to your final assembly. And in each step, there's different cleaning processes that need to happen, right? So if you consider at the very beginning at the die level, right? So we're going to be adding different types of different metallization layers, different like photoresists for different processes, and those all need to be cleaned, right? A lot of times those are cleaned with water because they're very sensitive, and the materials that they use are soluble in water. But even the machines that they use are very, very different. If you can think of like, if everyone kind of knows what the round silicon die looks like. So a lot of times those cleaners look like a record player, where they'll put the silicon die on the record player and then they'll clean it like that. There's no, mechanical scrubbing or anything. It's just purely, water. And then from that point, you have to do the die attach, right? So either you've added copper pillars or some sort of way to attach that to your interposer. And those mainly are going to be using water-soluble type fluxes. They want to be able to get rid of any oxides that form and make good bonds with the interposer. And so that product that you use there is going to be a little different than the product that you might use inside of your inline cleaner or your batch cleaner.
Sure.
And then, so those products are designed to make sure that they clean everything that is on the board that needs to come off, whether it's oxides or, those specific water-soluble fluxes. But they're also designed to not affect the functionality of the part, right? So like, for example, the metallizations. At that stage, the metallizations on the board are very sensitive, right? And so we need to make sure that we engineer that solvent to make sure that either the pH is in the right range, or if there are no bad chemical reactions that can happen to affect that. So then once that goes to the final package, the package part is going to be a completely different set of materials, right? Those fluxes, a lot of times they use no clean fluxes, which is a completely different beast to clean than the water soluble fluxes. You might imagine that if it's designed to be no clean or not cleaned, then it's going to be harder to clean if you want it to get off of there, right? I mean, it's, it has certain chemical additives that either they form like a shell to make sure that it doesn't, it's designed to be like a benign residue on the board, right? So it's not supposed to dissolve or react, right? So trying to develop a solution to clean those is different.
Yeah.
Right. And so
Excellent.
from a process perspective, that's very different. Now, the final end user, like if you're a contract manufacturer and you're going to use one of these advanced packages on your board, you have to realize that a lot of times they have very small dimensions to try to clean. The gaps between those different layers are very small. A lot of times the pitch of the leads can be very fine, if there's a lead at all, right? Like if you have like a flat pack that doesn't have any leads. The gaps can be very small. And so the cleaning parameters might need to change as well. And what I mean by that is either the time or the temperature or the pressure. You might have to slow it down a little bit, or maybe increase your temperature a little bit, or potentially change other parameters within your cleaner to make sure that the solution can get under there and effectively clean everything.
Excellent, beautiful answer. So I think that also relates somewhat these questions to what's the impact of components density, especially the lead pitch, which is always reducing on cleaning.
Yeah, that's a great question. So the biggest impact is going to be the geometry, because you have a lot of times smaller parts that are packed in together, right? And that leaves two problems. One, there's the gap underneath the part where the flux residues end up, right? If you think about, like, for example, like a QFN, or even a passive component like a capacitor. Or let's say you have a small capacitor, you have the two pads on either side. The flux residues will end up wicking underneath, and it'll be underneath that component. And you got to get it out. Well, the smaller that gap is, the harder it is to get out, right? So that's the first problem. The second problem is going to be shadowing. Because if you can imagine let's say you're washing your car, right, and you got your hose and you're spraying the car down, it's easy to get to it. But if you got someone standing in the way, like let's say you're in a parking lot, there's another car, it's hard to get it because there's a physical barrier between that. So making sure that we can get fluid flow down underneath those components and effectively cleaned is a challenge. Now, there are a lot of different ways around that. First of all, the chemistry designers like KYZEN have made sure that we give our chemistry the best chance to get underneath those components. So adding things like surface tension modifiers to reduce that surface tension to make sure that it can get under there. And then, of course, rinsing is a big issue too. It not only does it need to get under there, but it needs to get out. Right.
Yeah.
And so being able to get a product that rinses well is also key. That's also, pulls in another point where a lot of people think that you can use DI water, wash alone, especially with water-soluble fluxes. You think, well, it's water-soluble, right? Why can't I just use water? It depends, right? If you have a nice big board with relatively large standoff gaps, then that might not be a problem. But if you start to get, components that are really low and they're very dense, then water might not do the trick. You might need a little bit of chemistry just to get under there, to get out. Even if it's soluble in water, you can't clean it if you can't get to it.
Right.
Yep.
Absolutely
Yep.
true. No, very well explained. So now coming to KYZEN, what kind of top KYZEN products are recommended, or you can give some example for cleaning in electronics?
Yeah, of course. And so whenever someone asks me about, which product should I use, like what's the best KYZEN product, I hate saying it, but it depends, right? Because like I mentioned before, there are many different processes, there are many different applications. And so KYZEN, we pride ourselves on making products that work well within a specific application, because, a product that you might put in an ultrasonic cleaner might be very different than a product that you put in an inline cleaner. There are a lot of things that people don't necessarily think about, like, for example, foaming is a big issue. If you have an ultrasonic cleaner, it might have a certain formulation to be able to clean a part that's in that ultrasonic bath. Now, if you take that formulation and you put it in a spray and air machine, like an inline cleaner, it's going to look like, you filled your dishwasher with too much soap, and it's going to start overflowing with suds and whatnot, and you're going to be mopping the floor, right? And so, obviously, that particular product won't work in certain applications. And so what we say is call us, let us know what your application is and what you're trying to clean. And because that's the other big part, like what's the soil that you're trying to remove, right? Are you trying to remove flux residue? If you're cleaning a flux, is it a water soluble flux or is it a no clean flux? We have a lot of historical data from, we have relationships with the different manufacturers of fluxes and solder pastes. And so we know which of our products cleans, whatever product you decide to use, right? And so that being said, I'll say that we do have a few of our flagship products that do work well in a lot of cases. So for example, on the die, the advanced packaging like die side, where you're making the dies and doing the die attach and all of that kind of stuff, we have our Micronox products. So for example, Micronox 2708 is one of our main products that we use in that area. It seems to do very well in the majority of those types of applications. And then on the assembly side, we have our Aquanox products. In particular, we have 4625 and 4727, which is the kind of the newer version of the 4625, kind of, right? But like I said, they're all designed with certain applications in mind. And those two seem to, like I said, do very well with the majority of the current day fluxes that are used in a lot of different manufacturing facilities, and they don't see, the bugs have been worked out, right? So we kind of know what the problems have been, and we've been able to fix them
right
over the.
Excellent answer. And now in the electronics manufacturing, IPC plays a very important role, and there are certain standards for every processes and so on and so
Correct.
forth.
Yep.
What are the IPC standards for cleaning process in the PCB? The board assemblies,
Yep, that's a great question. So I'd say the main IPC standard that's referenced is IPC J Standard 001, and that's the requirements for soldered electrical assemblies. So basically, if you're making an electronic assembly, this is the document that it's the beginning of the tree. So within J Standard 001, there are many sections that have all the different different processes. One of them is the cleaning process. It's section 8 called cleaning and residue requirements. Now, in section 8 of J Standard 001, the biggest takeaway is that it requires you to have a qualified process. It doesn't tell you necessarily how to do it. It basically lays out the rules for what the qualification should look like. Like what constitutes a qualification? Like what data do you need to have a qualified product or a process? And then if anything changes, what constitutes a big enough change for requalification and things like that. Right. So J Standard 001 basically just says you need to qualify and you need to do it as, you need to have a qualified process. It doesn't necessarily tell you how. It does say that you need to provide objective evidence, and it gives you a couple different reasons or a couple different options for that. So for example, you can either have historical evidence, if you've been making the same product with the same process for many, many years, and you have all of this field data and historical data that says that this product is fine, there's no issues, right? That counts as objective evidence. But if you don't have that, then there are a couple of tests you can do. You can do SIR is the biggest one that's pointed to, right? And so SIR, again, J Standard 001 doesn't tell you how to do that test. It just says that SIR is an acceptable test to provide a qualified process. Now, the IPC also has a handbook, a cleaning handbook. It's IPC CH65, and it's it has to have at least 200 pages. Everything you would want to know about a cleaning process. Everything from, what's the difference between an aqueous versus a semi-aqueous versus a non-aqueous cleaning agent versus the different types of machines. You have batch, inline, ultrasonic, versus all the different considerations that you might want to take when doing a cleaning process. And so even the testing, right? So I was going to say those are the only two. Well, I say a lot of J standards just reference cleaning. Like if you just do a search for the word cleaning in any J standard, you might find the word in there once or twice. Those are the two. The J Standard 001 and the Cleaning Handbook 65 are the two biggest that have the biggest sections on cleaning. Now, they reference other J standards or IPC documents that help with that. So for example, there is a SIR handbook. It's IPC 9201. And that's another very large handbook. It has many, many pages on how to do an SIR test, all the theory behind it, if you want to understand, what's actually happening on the circuit board, how the system should be set up, even the, I believe, Actually, so in 9201, the requirements for the results are not there. I think it says, the low level is 10 to the 8th ohms.
Okay.
But in J standard 004, which is the requirements for the soldering fluxes, there's a
Yeah.
section on the SIR test, and it actually has the limits laid out. So you have to do a control sample, you have to run your tests. The test is 7 days long, but there's some caveats about, what happens within the first 24 hours versus what happens at the end. But that document goes into all of those details. And then there are the IPC test methods. So it's the IPC TM650, which is
Okay.
the test methods documents, which goes into how to actually run those tests. So for example, there's one on IC, which is 2.3.28. There's also
Okay.
one that talks about the ROSE test, which is 2.3.25. And then there's a test method for the SIR test, which is 2.6.3.7. And so in those documents, it has actually all of the details, the procedures for how to actually run those tests and then how to process the data.
Excellent. A lot of information there. I think
Yeah.
you have the wealth of knowledge there and the
Thank you.
library. And so, Adam, one thing is, people keep asking. There was a question here also about, when you have these adhesives and, epoxies, which are
Mhm.
used on the PCB level
Mhm.
or the component level,
Yep.
conformal coating and stuff like that, and especially on the adhesives, component to the PCB. Do you have like solutions to clean those from Kaizen?
Yes. Yes.
Okay.
So it depends on the process. So there material compatibility is always an issue. And so we strive to make sure that we at least understand what those issues are. So we have an applications lab here at Kaizen where we test all sorts of samples. We test labels, adhesives, tapes, you name it. If it's going to be on a printed circuit board somewhere in a circuit board assembly, then we've tested it. One, to make sure that the material itself is compatible, right? We're not going to, dissolve it away or
Yeah.
harm that material in some fact. And then also the function of that. So for example, if it's a label and you want to stick a label on your PCB and you put it through with our chemistry, two things need to make sure. You need to make sure that the label stays on, right? You can't wash the label off. And
Yeah.
two, you got to still be able to read it. Like, it doesn't matter if the
Yeah.
label's still there. The ink has to be readable, right? And so we do all of that compatibility testing here in our applications lab. We have years of data for hundreds and hundreds of products, so we know exactly which types of materials are compatible and which are not. Now, that being said, we want to make sure that our materials and our cleaning chemistries are compatible with the
Mhm.
majority of what our customers are going to be using. So, for example, like a staking adhesive. Right? A lot of times those are epoxies, or they're epoxy-based staking materials. And so we make sure that we design our chemistries so that they don't attack epoxy materials. Now, there are some things that we just can't get away from. Like, so for example, like silicone residues are a problem in electronics manufacturing applications, right? Silicone residues can prevent mainly bonding, right? It can get in the way of bonding applications, either adhesive bonds or wire bonds or things like that. Uh, those types of chemicals are susceptible to more types of chemistries, right? And so they're
Right.
harder to clean around. What we talked about before, it's selective clean. I want you to get rid of the residue, but I want you to keep the stuff that I put there intentionally. And
Right.
so I'll say, you can't get 100%, but we strive to do the best we can to just get rid of the residues, make sure that everything is compatible, and then make sure that the board functions after it goes through the cleaner.
Absolutely brilliant. I think people are happy with your answers so far, and I
Oh,
think
thank
we
you.
are almost coming to the end of the show. Before we wind up, any special message from your side, Adam, to the audience?
I would say that I get a lot of questions about cleaning. What do I do? Like
Yeah.
a lot of people, I'll say nobody wants to clean. I don't know. I haven't met a single person who says, I can't wait to add a process to my manufacturing line to spend more money and clean my boards. No one does that. And so when you're required to do it, either, let's say your customer wants you to do it, or you're making a board that, it honestly requires you to clean it. It's going to be on a jet somewhere, and, the plane needs to, take off and land safely. They don't know where to go. They're just like, what do I do? And so, a lot of times, I'll start with, listen, so you got to make sure you pick a chemistry that is balanced and it has certain properties, right? So first of all, it's got to be able to clean, right? You want to make sure that you pick a product that cleans whatever you're trying to get rid of, right? There's no point in using a product if it doesn't actually clean. Second, it's got to be compatible, right? You want to make sure that you talk with your cleaning supplier to make sure that not only are you getting rid of your residues, but you're leaving, your board behind. You don't want to ruin anything. And another big one is it has to be controllable. Right? A lot of these processes use gallons and hundreds of gallons of cleaning solution, and it can be expensive, right? And so if you want to run an inline cleaner or even a batch cleaner, right, you want to make sure that you can control that process. Some chemistries are much more easily controlled than others. KYZEN has our own setup. That's one of the things that we do before we release a product, is to make sure that it's controllable, right? Because the last thing that the customer needs is to have their bath concentration go way out of whack, and then all of a sudden the board comes out the end of the cleaner and it's not clean. So we provide those solutions not only to make sure that it's cleanable, but we also provide the controllers to do that. And then the last thing is the regulatory compliances, right? A lot of people have regulatory compliance, like what are they allowed to pour down the drain? What are they not allowed to pour down the drain, right? If you're talking about gallons and gallons, hundreds of gallons of chemistry, what are you going to do with it when you're done, right? Paying for hazardous waste disposal is not acceptable. And so we make sure that we design our products so that they meet the majority of local municipality regulations for sending things down the drain. So it's not, not an issue. So when it comes to selecting a cleaning chemistry, it's a daunting task, but we at KYZEN have made sure to make that as easy as possible to make sure that we meet all of the customer's requirements as well. Because when a customer succeeds, we succeed.
Absolutely. A fantastic answer. So thank you very much, Adam, for taking time and joining this talk show today on global electronics and sharing your wealth of knowledge about the innovative cleaning solutions on the electronics manufacturing. And definitely KYZEN is a company, one of the finest companies that is being in the electronics industry for years together now. And you guys are, absolutely doing great, I think, work there in the electronics manufacturing industries. So we wish you all the best, Adam, and look forward to many more episodes with you, because probably I would be interested in doing some kind of a panel discussion between the people who manufacture the adhesives, the electronics application adhesives. It can be thermal interface material and so on and so forth. And how we can have the residual, getting cleaned, and the solutions from you, that is KYZEN Corporation. So we can have that some kind of a panel discussion in the future. So for today, thank you so very much. Have a wonderful weekend. And if I don't speak to you, have a Merry Christmas and Happy New Year to you. And we will be in touch for as always. And thank you very much, audience, for joining the show today and putting these questions way ahead before the show, so that I could address this during the show. And thank you, Sandeep, for being there always and supporting the A&V perspective of the Global Electronics Talk Show. With that said, we'll see you again next Friday with another interesting topic. Till then, be healthy, be safe wherever you are. And we will see you next week at the same time. Thank you very much.
Thank you.